right, so now the next one is problem number 25 out of your textbook. So 3.5, problem number 25. And problem number 25 says we have the common log of x squared is equal to 6. Okay? And so our goal, we want to solve for x. Does that make sense? And I'm not quite sure, like there's 3 ways to solve it. Sometimes one is easier than the other. Remember that the common log is a base of 10. And remember the relationship, if I say the log base b of x is equal to y. And you know what, I'm going to replace that x with something different. So we'll say log base winky face equals y. And then the relationship of that is b to the y is equal to winky face. Right? So then that means I've got 10 to the 6th is equal to x squared, right? If I write it that way, is that right? Now in my solution manual, it raised like, well, I didn't like the way the solution manual did it. It was kind of long and complicated. This is a much easier way. So now remember, x squared is equal to 10 to the 6th. Now if you write that out, it's just 10 followed by 6 zeros. Right, which is 1 million. And so if I want to solve for x, we're going to have 2 solutions, right? I'm going to have x is equal to plus or minus the square root of 1 million, which I think is 1,000, right? So, but just to be on the safe side, we're going to double check that on our calculator, all right? So I'm going to say the square root of 10 to the 6th. Now your calculator is only going to spit out the principal root, which is 1,000. So that means I've got x is equal to plus or minus 1,000. Okay, does that make sense? And then we could probably, just to make sure, we might want to double check to see if that is an actual possible solution because of that negative solution. Remember, Mr. Adams talked about that. Now we know that when we have the absolute value of x, or x squared, which kind of acts like an absolute value function, that it's true. But I just want you guys to get in the habit of double checking it. So remember, another way that we could solve this equation is I could take this left-hand side of the equation and put it in my calculator like y sub 1, and then I can put this in my calculator as y sub 2. So I put the left and the right side of the equal signs and graph both functions, and then find the intercepts, right? You guys remember that? So let's do that real quick. Now, it shouldn't take that long. Well, it will because I got to clear out a bunch of stuff, but... So on the first one, I'm just going to say the common log of x squared, right? And then on the other one, I'm just going to put 6. And now we know that the graph has got to be set up a certain way because we got plus or minus 1,000. So I'm going to say minus 1,005 for my x minimum, and then 1,005 positive 1,005. And our y min is our maximum and minimum y value. And we're looking to where it equals x, or y equals 6. So I'm going to go a little bit above 6 and a little bit below. So my y min will be 5, and my y max will be 7. Let's graph those bad boys. So the red line, when we do the x squared in a composite function, x squared sometimes acts like when you put it inside another function, it'll look like an absolute value function sometimes when it's in a composite function. And so what I'm looking for are these 2 intersections right here. And we already know it's 1,000 and negative 1,000, so we're double checking. So what I'm going to do is I'm just going to hit trace. And, oh, I gotta turn my plot off. That's from yesterday. Don't pay attention to that. Let's turn those off. Option number 4. All right, now we'll go back and graph. And so we're just interested where the green line intersects the red line, and we know that it occurs in when x equals 1,000 or a negative 1,000. So what I could do is, if I want to do it graphically, there's lots of ways we could do it. If I hit trace and I enter in negative 1,000, my y value should be 6 on the red line. And if I enter in 1,000, it should be 6. Now, we're lucky because it's a nice integer answer. Another way you could do that is if you hit second trace and you go to option number 5, where you find the intercept, and I'm already at the second curve, and I'm going to let it guess. And it says the intersection occurs at x equals 0. You got, or 1,000. You guys laughing because my voice cracked a little there? All right. So now let's do the other one. Second trace calculate. Then we're going to go to intersection. But now I want to move the cursor. Oops, I want to go to the green one. This will take a while because we got to travel like 2,000 units, right? It's going pretty quick though. Oh man. There's always like a delay on my calculator too when I record the videos. All right, gotta get close, gotta get close. Okay, that's close enough. Boom, 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 and negative 1,000. One last way to double check that, go into your main screen and just take the common log. Whoops, let's erase those. Just take the common log of 1,000 and see what you get. Okay. Oh, wait, it's not 1,000. What was it? It was x squared, right? So it should be 1,000 squared, right? Boom. And then if we did the same thing with the negative 1,000, we get the answer.